Now let's try this example here. Find the slope of a graph. Now notice with this example, it just gives us the equation. Use a limit process to find the slope of f of x equals negative 2x plus 4. That is different from the last problems where we're given an equation and a point. So this is how you would approach this problem. We're still using the difference quotient. So let me write that again. So the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to plug that in to here. So we have the limit as h approaches 0, and we have negative 2 times x plus h plus 4, and then minus our f of x. And so that is this whole thing over here. So it's a minus negative 2x plus 4 all over h. So again, you have to attend to precision, be very careful. Number one, that you put the parentheses and make sure that you plug in the correct thing. So like that should be a negative inside. So now we have the limit as h approaches 0. Let's simplify everything. This is negative 2x minus 2h plus 4, and then distribute. This becomes a positive 2x and a minus 4 all over h. So then let's combine like terms. So negative 2x and 2x cancels out. Positive 4 and negative 4 cancel out. And now we're looking at the limit as h approaches 0 of negative 2h over h. And now our h's cancel. So we're looking at the limit as h approaches 0 is negative 2. So there's nothing to plug in here. So our answer is negative 2. That is the slope of f of x equals negative 2x plus 4. So try this next example. Use a limit process to find the slope of f of x equals negative 3x plus 4. All right, so hopefully you plug this all in correctly. So here is what it should look like when you plug it in. And then when you simplify everything, you should get a slope of negative 3. So it's important to know the difference or see the difference between the ways the different quotients were set up in examples 3 and example 4. So we just did example 4. The previous video was example 3. In example 3, you found the slope of a graph at a specific point. To find the slope in such a case, we're going to use this form of the difference quotient below. The only difference is, number one, you're just plugging in that x value and then finding out what that answer is. Now, if you're finding a formula for the slope at any point in the graph, then you're using x instead because we don't know what the x and the y value are. We're just trying to find the slope. So notice this equation here. Now this form, the second form, will always produce a function of x, which can then be evaluated to find the slope at any desired point on the graph. So that's really cool about that. If we wanted to find it at 6, 7, for example, or wherever that we choose, then we can find it by using our equation that we found. So negative 2, for example, it's always negative 2, and this is always negative 3. So again, look at the two differences. Example 3, we plugged in the x value, and then example 4, we're actually finding the equation. So let's find a formula for the slope of a graph. Find a formula for the slope of the graph of f of x equals x squared plus 1. And then we want to find the slopes at the points of negative 1, 2, and 2, 5. So there's a little bit of work that's going to go into this. So we're going to find first of all the formula. So we're going to tie it all together. So we're using that difference quotient. Number 1, find the equation of this, the slope. And so the slope of the secant line, remember that's our f of x plus h minus f of x over h. And again, we're finding the limit as x approaches 0 there, or h approaches 0, I apologize. So we're plugging it in here. So there's an x here that we're plugging that into. So first, this is going to be x plus h squared plus 1, and then minus f of x, so that's just minus parentheses x squared plus 1. So again, be careful with those parentheses, and then all over h. And then, of course, one thing that I forgot here is, of course, you have to write the limit as h approaches 0. So don't forget that. All right, so let's go ahead and finish this out. So x plus h squared, that's going to be x squared plus 2xh plus h squared, and then plus 1, distribute the negative, negative x squared minus 1 all over h. And again, this is a limit as h approaches 0. So let's simplify. So we know that x squared cancels, and then 1 and 1 cancels. So now we're left with h squared plus 2xh all over h. We can factor out an h. So this is going to be h plus 2x over h, or the limit as h approaches 0 of h plus 2x. And then when we plug in 0, we're going to get the equation 2x. So that's one thing that we're looking for. Find a formula for the slope of the graph. So there it is, 2x. Now we want to find the slopes at the points -1, 2, and 2, 5. So all we need to do is plug this in. So we're looking for the slope at the particular point, -1, 2. So we're going to plug it in here. So you're only plugging in, first of all, the x value. So this is 2 times -1. So the slope is -2. So the slope at -1, 2 is -2. That is what we're looking for. Next, we're going to find the slope at the other point. So that is 2, 5. So we plug it in. So 2 times, again, 2 equals 4. So the slope at 2, 5 is 4. So next, you try this example. Find a formula for the slope of the graph of f of x equals 2x squared minus 3. And then what is the slope at the points of -3, 15 and 2, 5? Okay, so hopefully you plug this all in correctly here right at the beginning into the difference quotient and then solve for it. You would find that the slope of the graph of f of x equals 2x squared minus 3 is 4x. Then you plug in each of the points. So the slope at -3, 15 is -12, and the slope at 2, 5 is 8. Now, just as a side note, now say for instance you're trying to do example 3, like if you do it in the homework, and you don't plug in the x value like here. So for example, you approach the problem by just using the x plus h and you get the equation here. You can always just plug in that x value in here, like if this is 3, just plug it into the equation and you will still get the same answer. And so hopefully that makes sense to you, because I know sometimes I always go straight to finding the formula, then I plug in my point. And so if you do that, for me, that's okay at least.